All right, so as this second week begins to wind down, it says finish chapter 1, which we will have no issues in completing today. You have some papers that are due tomorrow. And then also your first big evaluation. Tomorrow will be pretty busy for this classroom where, so you're almost, so third hour, fourth hour, sixth hour, and then 8th hours today. Yes, so let's try to get started off on the right foot, which means off to a good start. Maybe we're slacking off in that first hour class. No? Yes? No? Okay. Organic compounds, yeah. We start the reactions next week that accompany this. See, that's what's different with general chemistry as opposed to organic. You have to name all the compounds, and it's the reaction mechanisms that accompany those compounds. That's what makes possibly the course a lot more difficult, and it should be. It's a senior level class. All right. So, what can you tell me about animals' eyesight? Like, an example was the Utah raptor, the velociraptor. There was something about the cranium of that animal. And it actually had a crest that separated like blinders like this. So it would be difficult for them to see anything over there or over here. But what did their skull eventually do? What did nature select that skull to do? And that's exactly what it did, but when it narrows, it also becomes what? What are we illustrating? The snout would become longer, and it would become narrow, like you had mentioned. And what that's leading to is, again, this binocular vision, which would be an advantage for any type of animal. Yes?
So that's when its eyes are in the front of its head?
That's why they're in the front of its head. And I think it's believed you could say, you can almost tell what type of animal, where it fits on the food chain, just by looking at its face. And I think there's probably a lot of data to maybe back that up. Because how many people are driving or from out of town that drive in the country to get here to school? I don't know if it's anybody here. Okay. Are you noticing deer on the move too in the morning?
Not much, mainly around like October, November.
Okay. I've noticed that driving, picking up students in the bus every day, that there's deer on the move, and I would think that's kind of early for that too. I don't know. I'm not a naturalist or a biologist or a zoologist, so I wouldn't be able to tell one way or the other that, yeah, this is typical, or no, this is not typical. The reason I wanted to bring that up is, where would deer fit on the food chain? Are they predators? Now, that's a trick question. Do they prey upon anything? That's why it's a trick question. I suppose you were maybe being too specific, but think of what their diet is. Yeah, so plant, corn, and that's a type of plant too, so they're herbivores. So technically speaking, you say yes, they prey upon grass and other type of plant substances. I said, I don't know, that's what makes it a trick question. But that's not what we're getting at. The eyesight of these animals. Is it straight to the side? Is it straight forward? Or maybe is it in between the two? Probably in between. It's when the students have been talking about chickens, that because we see some of them and we're picking up some of these students. So when you look at their eyesight, are they to the side or are they straight ahead? Okay, so then when you look at Jerry back there above the door, what type of vision does Jerry have? It would be binocular, but is vision really going to help owls? Not really, okay? Because how if vision doesn't help these animals, nature selected them to have something happen in their skull. And I don't think you're going to know the answer because you haven't been taught that yet. But does anyone happen to know why owls navigate the way they do? And it would have something to possibly do with dolphins when we talked about them. Okay, so dolphins use a form of echolocation, and owls use something not exactly like, but you could say it's almost the same concept on hearing, not sending out a pulse, but what they actually perceive. So what happens in dolphins is that when you look at your tooth structure is usually pretty symmetrical, where with dolphins, the top teeth and the bottom teeth are offset just a little bit. The reason that's significant is that when a pulse of echolocation goes out, and when it returns, they can feel it on one side of their jaw before the other. So that would tell the animal to navigate left or right because of how it perceives that. Owls, you could say, maybe takes that just a step further because it's their ear structure is not symmetrical. That's asymmetrical, okay? So not only is one higher than the other, but it's going to be the cusp on the angle of the ear that when it perceives sound, if it reaches one ear before the other, that tells us this way. And then if it comes from below, it'll reach one ear before the other. So it helps them navigate left and right and up and down, which is something they would need to do if there's really no light around. Then finally, what is it that the author of this educational video said? There's something in the eyes of these mammals. It's a specific structure. We talked about it, but I don't know who we wrote it down. It's tunica something. Then the second word starts with an L. Anyone remember? It's called tunica lupidium. So when light comes in from either below, above, the side, when it hits the back of that retina, what does that tunica lupidia do with those photons or light rays? Does it absorb them or send them back out? It does. So it gives them an extra opportunity to absorb some of that light to magnify that. Do we have any hunters here with night vision? Is there a reason to use night vision at all? Have you ever used it?
Yeah, I want to hunt coyotes. That's about it.
Okay. So what would happen if you have, because we had to do some training on that too. You have a fitting on the top of your Kevlar helmet, and then it's an eyepiece that you fold down, and then it just fits over one of your eyes. But if you have that deal on, and let's say you're in a vehicle when you're doing nighttime driving, and you have to have blackouts, okay? What happens if you have this activated and you turn on the dome light inside? It's exactly. Why is that the case? You're right. It magnifies, not only is this optical lens gathering as much light as it can, now if you have a lot of light inside your cab when you're driving at night, it's going to hurt. It's going to burn the back of your eyes. It's not like you're going to go blind. It's just one of those aspects to where something like having a camera probably, and it's got the flash on there, and you're looking right in there, and then it just blinds you for just a little bit. So, yeah, I'm not a fan of nighttime driving, but that's in the past now. Okay, so we continue with, they use primates as an example, and that's one of the questions that's on your paper. So you probably really can't answer that until we wrap this up. We have what looks to me like we're at 28 minutes and 10 seconds, which means we have about 13 to 15 minutes left, maybe. So we'll go ahead and get this wrapped up, and then the rest of the time then will be yours after this educational video. Thanks to the History Channel. Okay, let me go ahead and get this set up, and then we'll get rolling. These times I'll have this set just right, because it seems like it's such a long stretch. I think the sound is okay when we pin this microphone up here. And the goal is not to fall on you, gentlemen, but that might hurt. You more than me. Okay. I will. So I gotta check the sound on it. I don't want to go gentlemen underwater.
Cambrian were larger and more mobile than any of the ocular field eyeballs.
Excellent new potential predator.
Group living was the primates'
Potential predator.
group li
Process works. Are there
My mistake, your fault.
Only a small number of species, including our primate relatives, can see a full range of yellows, blues, greens, and most significantly, reds. But such adept color vision does not exist in the earliest primates. Its evolution has its roots in the aftermath of a mass extinction.
About 66 million years ago, a gigantic asteroid caused the extinction of all non-avian dinosaurs and paved the way for the rise of mammals.
After the dinosaurs disappear, mammals radiate. All of a sudden they start diversifying, and one group of mammals is the primates, and they go straight for the trees.
Once primates settle into the forest canopy, they evolve into new species. One of those lineages becomes day active, the ancestors of today's monkeys, apes, and humans. They evolve a new adaptation in their eyes not seen in earlier species, an expansion of their color vision. A standard range of colors consisting of blues and greens now include red. Why would primates need to see red in their new world? For clues, biologists look to primates today.
Howling monkeys are this wonderful, unique animal that may give us some insights into our own evolutionary past.
Biologist Nate Dominy has spent his career researching primates as a means of understanding our own evolution.
They're almost like a time machine for looking at what the ancestral monkey in Africa and Asia might have been like. We might get clues to what its diet was like, its social behavior, its anatomy, and that ancestral animal was the one that gave rise to all subsequent monkeys and apes and ultimately humans.
Dominy wanted to know why natural selection favored improved color vision in our ancestors. What did they gain by evolving to see the color red? Dominy went on a year-long journey to study primates in their natural habitats.
part of my PhD research was to go to Africa to study monkeys with different diets and to study chimpanzees and to see if there was some sort of common or unifying food item that they might have all turned to that might explain why these monkeys all routinely share a very similar type of color vision.
Dominy scanned the rainforest canopy for test subjects, hoping to capture leaf samples from where the monkeys had stopped to eat. But he had a problem. What a monkey eats was high above his reach.
It's challenging, in the rainforest in particular. When an animal is at the top of that tree eating something, and you want the sample, there's not many ways to get it.
Left with no other choice, he had to take up arms.
We use this very stout, handmade slingshot from Panama that fire small pebbles up into the canopy, and leaves will come down. And it's a great way for sampling the types of foods that primates might eat.
After collecting and packing up the key samples, Dominy's real work began. Using an instrument called a spectrometer, he recorded the color of each leaf he had gathered in the field.
You see that peak in this green spectrum? So that's telling you that this is a green leaf. Now you see how, compared to that last one, this is peaking much more here in this orange region into the red region.
Nate's data yielded a remarkable discovery. Not only were the monkeys eating red leaves composed the majority of their diet. It turns out the redder the leaf, the younger and more nutritious it is.
Old, mature leaves, they're green leaves, they are tough, they're full of toxins. They're generally leaves you want to avoid. So primates in general tend to go for the youngest leaves possible. And if those young leaves also have a color cue that distinguishes them from mature leaves, then it may be advantageous to evolve a mechanism for detecting those young leaves.
To primates, red wasn't simply another color. It was a beacon, a homing device, allowing them to target their key food source from a distance.
If it sees red leaves in the canopy, then it knows automatically that those particular leaves are young. And so it can save energy, it can save time, it can travel directly to those young red leaves rather than randomly searching throughout its environment.
Increased color vision, a strategic evolutionary leap that scientists discovered was one of many. Primates would soon reap the rewards of another crucial adaptation, binocular vision. It's a trait that predators have repeatedly evolved. But for primates, it served a new function.
Primates have eyes at the front of their head, but they're not predators, so why would they do that? The great thing about having two eyes pointing the same direction is you get depth perception. If you're going to jump from one tree and try to land on another tree, depth perception is a really good trick to have.
Over time, primates evolved a binocular field of vision of 60 degrees, on par with birds of prey. It's an evolutionary step that allows primates to capitalize on their hand-eye coordination. But this increased binocular vision comes at a price. Unlike the rabbit, primates now had a limited field of view.
Most animals have eyes that are laterally placed on their heads, which is to say the eyes are on the side of the head. And this provides these animals with a panoramic view. And that's really, really useful for detecting predators that may be coming from behind you. So there's a significant cost to putting your eyes in the front of your head. But the advantages are that you have better depth perception, you have better acuity.
Once primates abandoned a vision system built for protection, birds of prey were ready to benefit. Swooping in from the sky and plucking primates from the treetops, these aerial terrors were threats to be reckoned with.
Based upon the evidence that we have from the fossils, birds of prey have been exerting some type of selective pressure on primates for as long as there have been primates and raptors.
Primates were easy targets for these winged predators. Under siege, primates evolved a new kind of behavior. They had to depend on each other.
You can imagine then that once these animals evolved eyes on the front of their heads, they needed to live with other animals so that they could improve the probability of detecting a potential predator.
Group living was the primates' answer to predation. It allowed them to maintain their high degree of binocular field of vision without sacrificing safety. Their keeping watch with a communal eye resulted in an evolutionary side effect: larger, more powerful brains.
So you can see the evolution of group living. And once group living evolves, you have a strong selective pressure, or you might say that evolution favored larger brains, because that's more individuals that you have to remember.
Fossils show how the visual system of primates improved over time. Both the eye sockets and the optic nerve canal grew larger as brain size increased. Primates put huge demands on their sight, from color vision to increased binocular vision. They became extremely sensitive to the slightest change of expression on the faces of other primates. This increased need for visual processing fueled the development of intelligence.
And you can see how this sort of runaway process for group living, larger brains, avoiding predation, could give you the suite of characteristics that define the primate order to which we belong.
A complex and mysterious organ. One that has fueled evolution for more than 500 million years. Driving an eternal arms race between predator and prey, and becoming an indispensable tool for millions of species. The eye, an engine of evolution, and one of its ultimate masterpieces.
So, one of the things I want you to think about is it's probably tough to see this, I wouldn't say ultraviolet light, but they're looking at leaves that are almost looks like they're indistinguishable, but when you actually have a better eyesight than what humans have, why are they consuming leaves that are red? Because humans, we can't really see the difference. I mean, in the fall, we can see that. Sorry, I didn't mean to interrupt. In the fall, we can usually see that, but not all year round like many primates can. I'm sorry, you were saying?
They're consuming it red instead of more nutrition.
And there's a side effect to that, too. Not only are they more nutritious, like you exactly said, what else might be true? Well, yeah, that's true too. But what if the older that leaf gets, it's going to appear more green? Then why not consume that they're not going to, because they've learned that. That's the process of learning. But they could consume them leaves, but they choose not to. Why is that? It has nothing to do with the nutrition. Well, not only is it toxic, but it probably doesn't taste very good. Now, the reason I say that is, and it could be similar to maybe with your parents or grandparents. Ideally, you're probably not coffee drinkers, right? But if you were to, like on Looney Day celebration, it was after the race got done running the 3 miles, 3.1, whichever. So did consume some water, and who else wants to run 3 miles? Anybody? Nobody? No. Okay. Anyway, they had a coffee truck? Not a truck. But when I went there, I'm looking at the menu and I say, do you just have regular coffee, black? Oh yeah, we got that. But should you decide to purchase something from that coffee truck, or whatever you want to call it, beverage truck, do you know what you're going to purchase? Is it hot or cold? Okay. So I like that idea of hot back there in the corner. What would it possibly be? Did you not say hot?
No.
Oh, I thought I heard hot.
I said hot.
Oh, what are you purchasing if it's hot?
I don't know, but I don't like cold coffee. I don't drink coffee. But
Okay. So then when you say that, that's probably a classic answer. Why don't you like coffee? Keep thinking that, but why don't you like coffee? Could be, if it's in excess. But the taste, it's bitter, so that's why it's an acquired taste. So would these animals ever choose to consume green leaves and continually do that? It would take probably a long time because they're toxic, like you had said. But what about fruits? What comes to my mind is apples. I don't know my species of apples and apple trees, but how would you know I'm going to pick this apple and not that one? They probably taste better. So one of the things that could possibly happen is that could very well be co-evolution taking place. What would we mean by co-evolution? What happens if you have co-captains in football? Tri-captains, quad, whatever you want to call it. Okay? But if it's co-captains, then it's what?
2 captains.
Yeah, you just have 2. That's right. So if it's co-evolution, not only would animals possibly be consuming the fruit on there that they know is ripe, but the plant allows that to happen because apples have what inside of them? I know nutritious materials, but what's at the core of that apple? Seeds. So if you have more animals consuming more of these seeds, what's going to happen to the dispersal of that tree, the descendants of it? Is it just going to be in one area, or is that going to be like a vector that spreads out? Why is it? You're right, but why is it going to spread out? Right. You have more and more animals digesting those seeds because they're more nutritious. That could be like a type of co-evolution that takes place. Okay, so that's enough for today. We will wrap up this chapter tomorrow with your vocabulary evaluation, and then we'll probably have your first large evaluation, maybe, I would say, Wednesday at the earliest, maybe Thursday, and then we'll get on to moving on to the Nidarians perhaps next week. Okay, we'll catch up to you next time.